The purpose of this video is to share with you certain concepts of double integrations and contours that can be fairly useful for you to visualize or understand a certain questions in terms of double integrations and contours related problems. So if you want to stay, I highly suggest that you stay. And therefore, to start off, do you ever question yourself, what is this thing and what is this thing and what are all these things, right? In terms of visually, not integrating. And I assume that you are already very professional in terms of integration. This is why you're here. Alright, so you're gonna integrate this dx first and then you integrate this dy first. So why do you do dx and what is the inner and the outer function that everybody are talking about? If you were to integrate this thing first, you're gonna set dx as the constant. So you'll not change along time, only this parameters change. So if you were to view graphically, for example, with some line, squiggly line, we have some x, we have a y. Alright, if you were to integrate in terms of the x first, right, you're taking just a slice of the x. So I'll just exaggerate a bit. This is actually dx. So you're taking all this dx's and then you just integrate along dx. As you can see, this point and this point, y is different, right? Y, it's different. I'm not asking you why is this different, alright? This is just talking about why is different, alright? Y is changing across time. And therefore, if you're integrating in terms of dx, alright, you're talking about y changing across certain parameters. So y is changing across this sector, alright? This is the meaning of that. So let me just if I were to instead of dx, now I change it to dy dx. In this case, I'm just keeping dy constant. So I'm just taking a slice of dy, another slice of dy, another slice of dy, and I'm just integrating like that. Alright, so as you can see, the different x point, it's always the same also, it's fine for this. Alright, but if it's in terms of certain stuff, then it's kind of different. But in this case, if you're talking about integrating dx, alright, you're integrating this form. Alright, if you're integrating in terms of dy, you're integrating this form, going in this direction. Alright, so please bear with this thing, alright? Please keep it in mind. This is the meaning of all this, alright? And what is this and what are all these things? Alright, these are the parameters, right? So for example, if I have some parameters, now we're talking about dx is constant, so we have y is changing, alright? So we are going to have some line that's slightly a little different. So we have some y that's changing across time. So imagine I have some y is equals to x, and this is y is equals to perhaps x plus 2, something like that. And therefore you have some two lines, right? So as you can see, y is changing in two different ways, right? Y is changing in two different ways. So therefore, one way for y is, so if you were to integrate, alright, you're taking one slice, and then also another, the top parameter, alright, the top parameter, this top parameter is this one, right, which is x plus 2. So I just split it over here and then minus away the orange color one. Hope you get what I mean. So the orange color one is the bottom one. So when you do that, you're taking only this slice over here. Alright, you're taking only this slice. You see, you're taking only this slice. And therefore you're gonna know which sector are you talking about. Alright, so this is the key concept that I want to convey. And therefore, if you have something different in the outer one, then you have different methods. but this is generally the case. Alright, and therefore let's continue first, right, since we are already here. So we have some x, we have a y-axis, right? And this function, alright, the meaning of this function is in terms of some z-axis, alright, some z equals to x, some x and y. So z is in terms of some x and y things. So it's in terms of some 3D, alright, if you talk about it. So in this case, I just let my function is equals to some x squared plus y squared to keep it simple. Alright, x squared plus y squared. How do you visualize this? Alright, this can be very abstract, so just hold on tight and just chill a little bit, and just be happy, right? So we have an y-x plane, alright, just extend all this thing. So what we have just now, the xy plane, alright, this is the xy plane that we have just talked about it just now. We just translate it into this from here. Alright, I'll just translate it into here. Alright, I'll just draw it over here. So we have a different color, perhaps this color. So we have this portion over here. Yeah, we have just integrated. Right? And therefore, alright. Now we're gonna introduce you the function. What is the definition of this function? What the meaning is this? Is that x squared plus y squared, for example, if the function is x squared plus y squared, alright, if I were to put it like that, alright, this means that, for example, do you see that you have x and z, right? So we're gonna talk about the zx plane first. So we're gonna talk about all this plane, this plane. If you were to visualize this properly, we're talking about this plane. I hope that you can somewhat visualize this plane, alright, zx plane, alright. And therefore, zx, the relationship between z and x is what? It's parabola. It's a parabola. So I just draw it like that. This is the parabola. Alright. And similarly, we have some zy also. So we are talking about this plane now, right? Z and y. We're talking about this plane. And therefore, we can also draw another parabola. If you don't know what the hell is parabola or what the hell am I talking, for example, x squared is equals to z. Alright, so if I sub in x squared into the calculator, alright, what do I have? Dang, no, x squared. Alright, I would have this shape, right, parabola, and this is called parabola if you don't know. So parabola is just what I've just drawn just now. So x and z is in terms of some parabolas, and therefore you can somewhat relate to it in a slightly different way, although it is not intuitively there. But I'll just draw out the shape so that you can know what is the actual shape look like. Alright, you know what, I'll just draw a view. Alright, I'll just draw a view. So imagine we extend that zx into two corners. Alright, so two sides. Alright, this is the one side. I'll just draw it in terms of two sides, and then I extend another to this another side. So this is the y one. You can see that there is some plane going on, and the rest is just some bow shape type of thing. Right, if you can't visualize, this is what I'm talking about. Alright, this is the shape. Alright, so as you can see, if I were to go into zx plane now, this is some parabola. Alright, at both ends, right, at one end and the other end. If I were to switch it in terms of some zx now, I have another parabola, because x squared plus y squared. Hope this really helps. And therefore we have explained what is x squared plus y squared. It's just the graph itself. And therefore, what is the double integration? Alright, the double integrations is to find, at first we have to find this thing, right? Is to find this and along the height of that. So you're gonna get something like that. If it's 3D now, you're gonna take some shape. You're gonna integrate all this stuffs. So this is some height that you want. So you're just talking about this piece over here. Alright, I don't know whether you can visualize it nicely, but this is some piece over here that I'm talking. So it's just taking a slice of a cake, something like that. Alright, so in terms of 3D, the x squared plus y squared is something like that, right? And then the below plane is something like that. So I'm just taking this piece. I'm just getting wherever that I need this one. Alright, I'm just taking all this. I'm just calculating what is the volume of this portion over here. Alright, and I hope that this really helps you, but I haven't finished yet. I'm just talking about integration part. And how does this link to contour? Alright, if you happen that you know what is contour, or you require to know what is contour, and you're looking forward to that, I'll just share with you. Contour is something in terms of top view. Alright, if you remember, contour is always in terms of XY plane. So now let's just go to XY plane. So we just go to red and green. So I'll just switch a little bit to the top view. You see that there is this ring of colors going brightly from blue to green. Imagine these circles and circles and circles. So this is similarly like that. So from the darker one to the orange one and going upwards like that. So visually, alright, it's ring by ring. So for example, if you don't know what the hell am I talking, for example, the graph itself, it shows that this is some circle, right? But you don't know what the hell does the circle means. So I'm just gonna show you what the circles mean. So for example, I have this graph over here, and perhaps I have this shape mark. Okay, I have this circle. This don't look like some circle. Alright, this is some circles now. And therefore, if I were to go into 3D, this little circle is at this base, right? And then the next ring, it's somewhat higher, and then the next one somewhat higher, something like that. So along the way, you can see that this makes a bow shape. Alright, even though that there's some sort of a palabra at the sides, but at least it kind of show that it is this shape. Alright, it is this shape in terms of this. So this ring tells you how deep it is. Right, the smaller it is, the further you are. Like if you're standing, imagine this is a well. Alright, your head is over here. Alright, your head is over here, and then you just look down, and then the deepest side of the well, it's kind of really small. It's just this is some brick. So the deepest side is way so small, so the water is down there. Alright, this is the meaning of contours. Alright, and therefore I don't how do I say, therefore generally I don't share the method of solving. I'm just sharing the concepts that may be helpful to you, and therefore in summary, I'll just discuss what are all these terms, and then also lastly the contour, how is it related to the double integral, and I hope that this really helps you to, and also that you can I will actually introduce you to these two websites. Alright, these two or these three stuff that helps you to actually understand how things works, and these are the tools that can help you to visualize things better. And sorry if this is not that useful, but I think that it's fairly useful. So yeah, see you soon.